Okay, hello guys. We are continuing with your project, grade 9, term 3, 2025. We are dealing with worksheet B, activity 1. It's a group work. Okay, so they are saying 1.1, state Ohm's law and write the formula down, showing the relationship between the voltage, the current, and the resistance. So I'm going to begin comments, or I'm going to start by writing the formula down. So I'm going to say okay, let me use here. I'm going to say I equals to V over R. This is the formula of Ohm's law. This is the formula. So they said you must write down the formula. I equals to, current is equals to voltage over resistance. Now we have to state this law in words. When you state it, you say current is directly proportional to the voltage and inversely proportional to the resistance. This is your Ohm's law in weights. You gave the formula. You also wrote down the formula, and you also stated Ohm's law in weights. Okay, now they say calculate the following 1.2a. Calculate the voltage. If the current is 6 amps and the resistance is 56 ohms. Okay, this is more like we are in science class. So let us calculate. The formula says I current is equals to voltage over the resistance. So let us use this formula to calculate the voltage. On 1.2a, they want the voltage. Okay, so we know that the current I is 6, and we know that the resistance is 56. I don't think it's 560. I think they wanted to say 56 ohms, but now it's 56, 0, 560. I think they wanted the other one there. They wanted to note the unit. I think the resistance is 56 there. I equals to 6 over 56. Then obviously we are solving for the voltage. We have to make V the subject of the formula. You can do cross multiply. You can say 6 times 56, 1 times V. So V is equals to 6 times 56. So how much is 6 times 56? Is 336. Is 336. Okay, so now we have to go to 1.2b. Calculate the current if the voltage is 1350 volts and the resistance is 2000 ohm. Okay, so I'm going to say they want the current. I'm going to say I'm solving this one. 1.2b, I will still say I equals to V over R. This is my formula. Now let me substitute on my formula. Okay, I is equals to my V. I've been told that V, the voltage is 1350. I've been told that the resistance is 200. So 1350 divided by 200. It's 6,75. So you are getting 6,75. This is your current. And then you must write capital letter A here to indicate the unit of current. So that was 1.2 B. Okay, I want to go to the what's happening. Okay, now I'm going to C. On C, they are saying if the current is 8 and the voltage is 450, calculate the resistance. So we have to calculate the resistance. You still use a formula here. I equals to V over R. You know that the current I is 8. The voltage it's 480. You have to calculate the resistance. So what you can do here now, you can do cross multiply. You can think of this as 8 over 1 is equals to 480 over R. So you cross multiply, you say 8R is equals to 480. You divide both sides by 8. The resistance is equals to 480 divided by 8. 480 divided by 8, which is 60. So it's 60. That is your resistance. 60 ohms. This is, you write the unit. Okay. So now it was 1.2C. So from here we go to, it was worksheet B, 1.2C. So where are we going from here? We go to worksheet B. We go to activity 2. Okay, let's check. We go to worksheet B, activity 2. Okay, here they are saying study the table below if the values for the voltage and the current for your circuit were indicated below and answer the question that follows. The first question says complete the table. It's 4 marks. Let's complete the table. When you complete the table here, okay, it's 3, 6, 9, 3, 6, 9, here is 2, okay? Obviously, we can see they are adding 0, 0.5 here. 0, 0.5 plus 0, 0.5, it's 1. 1 plus 0, 0.5, it's 1, 0.5. 2, we are going to have 2, 0.5 here. And then let's go to this one. It's 3, 6, 9. We can see they keep adding 3. They have got 12. They have got 15. They have got 18. So the table is complete. Now they are saying show that the relationship between V and I, show that the relationship is given by constant R. So they are saying show the relationship between V and I mean the relationship between the voltage and the current is given by a constant R. So they are saying according to this table, R does not change. So we can say, let us look at this one, this first relationship here. We know that I is equals to V over R. Okay, so what is my I? Is 0, 0.5. What is my V? It's 3 over R. So I want to calculate the resistance. I want to calculate the resistance. So I'm going to have 0, 0.5 R is equals to 3. Now, if you divide both sides by 0, 0.5, you divide this side by 0, 0.5, we can see that R is 6. So that was for the first relationship. If we do it for the second relationship, we will still see that actually R is still 6. So you say I equals to V over R. I there, it's 1. V, it's 6. If you solve for R here, you're going to have R equals to 6. So for every relationship on this table, R is constant. The value of R, it's always 6. Even if we do it for number 3, we say I equals to V over R. I there is 1,5. V is 9. If we solve for the resistance here, we're going to have 1,5 R cross multiply equals to 9, and you divide both sides by 1,5, R is going to be 6. So R is constant. R does not change. R is always 6. Show that the relationship between V and I is given by a constant R. Yes, R is always constant. It's 6. Okay, on 2.2, they are saying use the grid provided to answer the questions that follow. Plot the graph showing the relationship above where V is on the y-axis and I is on the x-axis. So we have to show the relationship. Let me write 3, 0, 5, 6, 1, 9, 1, 5, 12 and 2, 15, 2, 5, 18 and 3. I will need this table. Okay, use the grid provided to answer the questions that follow. Plot the graph showing the relationship above where V is on the y-axis and I is on the x-axis. So they want us to plot the relationship between the voltage and the current. And they are saying we must put the voltage on the y-axis. So this is what I'm going to do. I'm going to say voltage this side, and this side I'm going to write current. So they want us to plot the graph. So I see 3, 6, 9, 12, 15. So I can use the scale of 3. Let me say 0 here. 3, 6, 9, 12, 15, 18. That will do. Let's use the scale of 3. 3, 6, 9, 12, 15, 18, 21. On the current, let's use 0, 0,5, 1, 1,5, 2, 2,5, and 3. Okay, what was going to happen if I said 0, 0,5, 1,5? Okay, 0, 0,5, I mean uh, 0, 0,5, 1, 1,5, 2. No, it was not going to work. So the way I've done it, there's no problem. So now I'm going to plot the graph. If you remember on your table, you had something like this. You had 3, 3, it was mapping with 0, 0,5, and then 6 was mapping with 1, 9 was mapping with 1,5. Check your table. 12 was mapping with 2. So you're going to say, okay, 0, 0,5 and 3, it's here. They meet here. 0, 0,5 and 3, they meet here. Then you say 1 and 6. 1 will meet with 6. They meet here. Then you say 1,5 and 9. 1 comma, oh, sorry. Sorry, guys. There was a mistake there. Let me continue sharing. I'm very sorry. Yes. Okay, so where I was here. Actually, where I was. Let me, I'm very sorry, guys. Yes, I was here actually. I was trying to draw the graph. Let me put this here. It's actually the one disturbing. Yes, I was drawing the graph, and then in order to draw the graph, you have to look at your table. We had the table of voltage and current. And when voltage was free, current is 0.5. When voltage is 6, current is 1. When voltage is 9, current is 1.5. When voltage is 12, current is 2. When voltage is 15, current is 2.5. When voltage is 18, current is 3. So you have got 0, 3, 6, 9, 12, 15. Here we are referring to the voltage on the y-axis. We have got 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5. We are dealing with the current this side. So we know that 0, 0.5 match with 3. So we are here. 1 maps with 6. We are here. 1.5 with 9. We are here. 2 with 12. We are here. 2.5 with 15. Here. 3 with 18. 3 with 18. We are here. Then we draw a straight line. This is my graph. My graph is a straight line. Plot the graph showing the relationship above where V is on the y-axis and I is on the axis. This is my graph, but normally the graph must have a heading. So you say, okay, the graph, or you can say the relationship between voltage and current. Remember, the graph must always have a heading or a title. So this is the graph which shows the relationship between the voltage and current. You can write it in this manner. The graph that shows the relationship between the voltage and the current. Okay, that was A. Now I'm going to B. On B, they are saying, is the graph of the relationship between the voltage and a current an example of a direct or indirect proportion? Justify your answer. So I'm answering worksheet B 2.2b. So B, I'm going to say it's a direct relationship. It's a direct proportion. I'm going to say it's a direct proportion. Why? They said I must give a reason. I'm going to say as current increase, as current increase, voltage increases. Yes. As current increase, voltage increase. Okay. So this is a direct proportion whereby as the current increase and the voltage increase. Okay. Use any 2 points from the table graph to determine the gradient of the graph. Hence the equation in the form. So they want us to find the gradient and they also want us to find the equation. Use any 2 point from the table or from the graph. So I'm going to use this point here from the table. Or I can even show it on a graph. I can say on a graph, this point is 0, 0,5 and 3. And the other one, it's 1 and 6. Yes, and we prefer to start with the one which is on the x-axis. Current is on the x-axis, so we write the value of the current first. So we say 0, 0,5 and 3. We say 1 and 6. So I've got 2 points. Let me call this one point A, and let me call this one point B. So now I want to find the gradient of the point A and point B. So when you calculate the gradient, you say M equals to y at B minus y at A over x at B minus x at A. So you are calculating the gradient of a line. This is how you calculate the gradient of a line. You look at change in y over change in x. You take y at B, you subtract y at A. What is y at B? It's 6. What is y at A? It's 3. You take x at B, it's 1. You subtract x at A is 0, 0,5. So your answer is going to be 3 over 0, 0,5, which is 6. So the gradient of this line, it's 6. Now they are saying find the equation. You know the gradient, find the equation of this line. We have the gradient of a line. We must now find the equation. We say y equals to mx plus c. You say y equals to your gradient. This m here is the gradient. The gradient is 6. Y equals to 6x plus c. You just have to find the value of c. Then you have the equation of a line. Y equals to 6x plus c. It's an incomplete equation of a line. We just have to find C. How do we find C? Use any point from the line. You can use point B. You can say at B, my X, it's 1. My Y, it's 6. So you say Y, it's 6 equals to 6. Your X, it's 1 plus C. So the value of C in this case, if 6 times 1 is 6. If we take 6 to this side, it's going to be 6 minus 6 equals to C. Therefore, C equals to 0. So the equation of a line is y equals to 6x. C is 0, which is the same as y equals to 6x. This is the equation of our line. Y equals to 6x. The equation of this line, it's y equals to 6x. Now, D, I've answered B. This was C. This was the problem for C. It was 2.2. Worksheet B, 2.2C. Let me make sure. Worksheet activity 2, 2.2. Yes, C. This was C. Now we are going to D. Write V in terms of I by using the equation above. Okay? Here you just say D, you just say V is equals to 6I. Remember what on the y-axis, it is V. So we substitute y with V, we substitute X with I, because current is on the x-axis and then voltage is on the y-axis. So V equals to 6I. Okay, let me stop this and end my meeting.